Welcome back. So today is 7-3. We are working on the power to a power rule. I've already created 2 videos, 7-3 part 1, 7-3 part 2, and this is 7-3 part 3. So again, we're working on the power to a power rule. If you didn't watch the first 2 videos, you really need to go back. Please don't start on video 3. You are not ready for this. This is some shenanigans. This is a lot. So please go back and watch 7-3 part 1, then watch 7-3 part 2, and then you can watch this video 7-3 part 3. Both the in-class notes, which is what we're doing, and the homework are both online under your module, under the Canvas, on Canvas, okay? So let's take a look at this little guy here. Holy moly, we got a whole lot going on. We got a plain guy sitting here. We got all this jazz sitting here. Wow, oh, shenanigans. Oh, Basically what we're doing is putting every stinking rule that we've learned together to see if we have mastered them all together. So we are using our power to a power rule, definitely. We are using our simplifying rule of zeros and negative exponents. And we are definitely using our product rule, okay? So we have a lot going on here, but we can do it, right? We can do it. We can do whatever we put our mind to. So let's do this. So when I'm looking at this, I point to the area that looks the most, busy, for lack of a better word. You don't look busy. You're a YY, I gotcha. I'll look at you later. Whoo, yeah, oh, let's take care of this beast. I have inside a Y and an X squared. That's what's sitting inside. And I'm gonna share with just this chunk of 2. He's not getting diddly squat. If you remember the example that I used, I think in video 2, I talked about a classroom and the teacher sharing cookies. This kid's in a different class. He doesn't even know these kids got a cookie, right? So I'm not gonna randomly just run up to a kid somewhere on campus and hand that random kid a cookie. Stranger danger, don't accept sweets from a stranger. But anyways, this is one single class and I'm sharing with them only. This is not a kid that's in the class. So he's not getting the sharing. Okay, so this is what's inside the class and we are sharing a 2 with both. So here we go. You get a 2 and you get a 2. I'm just gonna tackle this first and then I'm gonna remember to bring this guy down later and make sure I deal with that guy. So y squared is just y squared. There was no power raised to an additional power. I have that here. Power to a power, I have 4. Okay, I cleaned up the part that looked the most cumbersome, and now I'm gonna bring down this additional piece. Oh, cool. Now this looks like 7-2, the product rule. So I'm gonna put these in order. X would go first, because I'm going alphabetical order. I'm gonna do this y squared guy, and then this other y squared guy. And again, if you wanna put that multiplication dot in there because it makes you feel good, you do that. So that product rule stated that if we have like bases, we keep the base and we add our powers. Okay, let's do that. You're a different base. You're all by your lonesome, Mr. X guy. You're X4. But these Y guys are like. Make Y something you can relate to. Gosh, the only thing I can think of is a yak, which is an animal. So I have 2 yaks here and I have 2 more yaks there. It's a lot of yaks. That's 4 yaks to be exact. Because when we have the same base, we have the same animal, we add our powers. Final answer. Cool. Now my suggestion would be to pause the video and try to tackle these last 3 on your own and then come back and watch me do it. You're like, well, what if I make a mistake? Well, that's where you learn. Well, what if I get frustrated? That's where you learn. Well, what if I have to erase and then do it again? That's how you learn. Learning's not linear. It's not like, oh, this is easy breezy lemon squeezy. It's like, I'm failing. This sucks. It's great. It sucks. It's great. I'm learning now. Okay, that's learning. Learning's cumbersome. Learning is challenging at times, right? And that's all right to push ourselves through it. We can do it, but you got to try. This is your time to try. So pause the video and you try these 3 and then come back and see how you did. Cool. Okay. So, welcome back. I hope you tried them on your own. Let's do 14 first, okay? So we have this beautiful little problem and this piece. Again, I go to the piece that looks like the piece I need to tackle first, which would be this, because I have parentheses and I have something going on the outside. So that's the piece I tackle first, okay? So here we go. I have 2, I have n, and I'm going to share with them a 3. Not too much else I had to do with that, because there wasn't a power raised to an additional power like this. Here we had a power to a power. We didn't have that. Okay, cool. Let's bring down the rest of this shenanigans and see what we got going on. Oh, yeah, looks like your room's pretty messy. You got to organize it. If this was a messy room, the first thing you would do is organize things. So kids look at their dirty room and they're like, okay, towel pile, shoe pile, clothes pile, water bottle pile, random kitchen utensil pile, right? So you're organizing it to simplify it a little bit better, aka clean your room. So I'm going to put the 2's together because I know they're like, there are coefficients. We have 2 to the 3rd, so boop and boop. Now we're going to put our n's together. We have n3 and we have n-3. That's interesting. Cool. And we have m3. Miss Miller, why did you put the n's first and not the n? Doesn't matter. I usually do alphabetical order. You can put the m first and then the n. It's truly up to you. Now I'm going to tackle these, but be careful. My coefficients, this is a little salty right here. We have 2 times 2 times 2. 2 times 2 times 2 is what? 8. And 8 times 2 is, right, 16. So this is technically 16. Now if you have to write this out so you can see it better, I say go for the gold. 2 times 2 times 2, that's 8. And 8 times 2 is 16. Now we have like bases here. And when we have like bases, we add our powers. 3 plus a negative 3. Well, if you're using a number line, 3 and a negative 3 make a 0, right? So here we are with 0, and we're going to have M3. Here we go.
Teachers and staff, just a reminder that today's drills are canceled. Again, just a reminder, if you check your email, that the drills for today are postponed, canceled for today. Thank you.
I really am at school. You can hear all the messages, right? Okay, so we have 16. Anything to the power of 0 is 1. And n to the 3. Cool. 16 times 1 is 16, and we have M3. Great. Good job. Is that what you got? I hope so. We got 2 left. Definitely tackle this little beast first, because he looks the most cumbersome. So I have x to the negative 1. I have y to the negative 3, and I'm sharing a negative 1 with both. Cool. I am literally sharing a negative 1 with both. I'm going to deal with this little piece later because I'm dealing with the one that looks the most spicy, for lack of a better word. So we have a power to a power. That's x. Negative times a negative is a positive, and 1 times 1 is 1. Why? We have a power to a power again. A negative times a negative is a positive, and 3 times 1 is 3. Cool. But don't remember, we have this little piece over here that we have to tackle as well. Great. Okay. Now our goal is to put this in order, just like you were cleaning your room. You got to organize, right? So we're going to put the 3 in the front. We're going to put the x's together. And the y. Now, if you don't trust yourself that you have the same ingredients, go and count. 1, 2, 3, and 4. 1, 2, 3, and 4. I still have the same 4 pieces. We're good. The 3, nothing to multiply it with. We have like bases. When we have like bases, we add. And then we have y3 left over. Cool. Final answer. I hope you got it. And last but not least, that one's the doozy. So give it a try yourself if you haven't. I already asked you to, but just in case.
Please rise and join me in saying the pledge.
Let's do the pledge. Do it with me.
Over your heart. Ready, begin.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, and liberty and justice for all. Right on. Woohoo! Okay, so you go ahead and try this. I'm going to rewrite this down here while they're doing the announcements. It really is a live video. Okay, so we have 3. We have a to the negative 3. And we have b to the negative 2. 1, 2, 3. So we have 3 pieces inside this beautiful parenthesis. We have a 3, we have an a, and we have a b. I rewrote those, and then I'm going to share the 2 with all 3 of them. All 3 of them are getting the 2. So all 3 of them. We have a 2, we have a 2, and we have a 2. So I'm sharing that with all 3 pieces. Cool. Awesome. I'm ignoring this piece for now because it's not the one that needs my attention. I am doing this one first. Beautiful. 3 squared, that's going to be 9. Power to a power, that's going to be a to the negative 6. Power to a power, negative 4. Now remember, we're not done because we needed to bring down these pieces right here. Now let's tackle it. Let's see what our final answer would be. I'm going to put like things together. So these 2 would go together. My A's are going to go together. Now that's an A1. I'm going to put it on there because I'm a visual learner. And then I have my B's. Perfect. Awesome. Okay. Now let's finish. 3 times 9 is 27. We have some like bases here. 1 and a negative 6 is a negative 5. And we have like bases here. We have b to the negative 3. Beautiful. We know that can't be our final answer, and the reason? You're right, we have negative exponents. And that's not allowed. So we're going to put it all over 1, and we're going to move what needs to be moved. The 27 will be on the top. The 8 to the 5th will be downstairs, and the b to the 3rd will also be downstairs. Final answer. So good luck. Make sure you print the 7-3 homework and give it a try. And remember, I did put the odds on the key so that you can check some of your answers. The whole thing's due though. Okay, good luck. Bye.